So this video is on second semester RFF number 1 review. It's the one with the gears on it. So I'm just going to draw a triangle. And I'll just adjust it because it's not. It's not necessarily isosceles, so I don't want to make it look like it's isosceles. Okay, so let's say that this is A, this is B, this is C. Okay, this is going to be 40 degrees. B is 71 degrees, and little a is 8.2. Now, when I have things that are across from each other, so knowing this angle with this side, I'm going to be using the law of sines, okay? Now, the problem is I am going to be asked to find little c, and I don't know the angle across from it, but I can find it. Because in a triangle, all the angles add to 180. So I can go 180 minus 40 minus 71. And so 180 minus 40 minus 71 is 69 degrees. So this angle C is 69 degrees. So now, if I want to find little c, and I know angle C, I'm going to use law of sines. So law of sines basically is I am going to take sine of 40 degrees over the side opposite it, which is 8.2, sine of 69 degrees, and then the side opposite that, which is C. I'm going to cross multiply and solve. So when I cross multiply, I'm going to get C times sine of 40 degrees equals 8.2 times sine of 69 degrees. I'm going to divide both sides by sine of 40 degrees. So I'm basing it at 8.2 times sine of 69 degrees over sine of 40 degrees. And I'm going to be putting this in the calculator, and I'm going to make sure my calculator is in degrees when I'm doing this. Okay. So changing this to degrees. And then I'm going to do alpha y equal to get my fraction. I'm going to put it in fraction. 8.2. Zoom in a little bit more. Okay. Just trying to get this better. 8.2 sine of 69 degrees over sine of 40 degrees. And I end up with 11 point, let's say 9 as my answer. So 11.9. So C back here, C is going to be 11.9. On number 2, write a polynomial equation for a graph that passes through the points 1, 12 and has 3x intercepts, -2, -3, and -1. So I know this is going to be of the form y equal a times x plus 2 because of the -2, x plus 3 because of negative 3, and x plus 1. And then I'm going to put in this point 1 comma 12 for my x and my y. And so I'm going to get 12 is equal to a times 3 times 4 times 2. So that's 12, 24. So 12 is equal to 24 a divided by 24. I get a is equal to 1/2. So my equation is going to be y is equal to 1/2 times x plus 2 times x plus 3 times x plus 1. Number 3, we're going to write a polynomial equation that has roots -2, positive and negative root 6. So basically, and it doesn't say that we have any, just says a, not the one. So we don't have to look for a stretch here for an a. So the x for the -2 is going to be x plus 2. And then I'm going to have an x plus root 6 for the negative root 6, and an x minus root 6 for the positive root 6. And these here, that's going to be a difference of 2 squares. So I am going to end up getting x plus 2 times, and when I do what's in the yellow, I can write x plus root 6 times x minus root 6, but that is a difference of 2 squares. I'm going to get x squared minus 6. And then I'm going to do this math. So let me do a box here. X plus 2, x squared minus 6. That's going to be an x to the third, 2x squared, negative 6x, negative 12. So my equation is going to be y equal x to the third plus 2x squared minus 6x minus 12. What is the remainder when you divide? So you can do long division, but you don't have to do long division. You can do synthetic division. And if this is an x minus 2, you're going to put a 2 in the little box. And you need to make sure we have, we're not missing a term. So I have a 5. I have a -2. I'm missing my x squared, so I'm going to put a 0. And then a 4, and then a -10. And then you always bring down your first number. So that's 5. 5 times 2 is 10. I add, I get an 8. 8 times 2 is 16. I add, I get a 16. 16 times 2 is 32. I add, I get a 36. 36 times 2 is 72. And I end up getting a 62. Now, this 62 is my remainder. That is my answer. Okay, so my remainder is equal to 62. If I was asked what I got when I divided, my answer would have been, since this was an x to the fourth, this now is going to be 1 degree less. So that would have been an 5x to the third plus an 8x squared plus a 16x plus a 36. That 62 was my remainder. So that would have been 62 over x minus 2. So that's what I would have gotten if they asked for the quotient. But they asked for a remainder, and that's the last number, which is 62. What's the sum of the roots? Okay, so we want to find the roots here. And so for this, what I'm going to do is I can do my synthetic division using 1, -9, 2, 48. I am going to do kind of a column form because I may not get it on first try. I would take the coefficients, and my lead coefficient is 1. My constant is 48. My P over Q is all things that multiply to 48 over all things that multiply to 1. So everything that multiplies to 48, 1 and 48, 2 and 24, and so on. Those are, I'm going to go through all of those. Let me try a one. One, I don't think one's going to work looking at these numbers. Let me start with a 2. Okay. So that's going to be a 2. I add 2 to -9, I get a -7. -14, I add to 2, I get a -12. -24, I add to 48, I get a 24. Okay. So at 0, it was basically 48 above the x-axis. Now I'm 24 above. So I am going down. Let's try a 3 because 3 does go into 48. 3 down to 1, 3. When I multiply, I add it to -9, I get a -6. -6 times 3 is -18. -18 plus 2 is -16. -16 and 3 is a -48 plus 48 is 0. So I found a solution. Now I'm going to take what's left, which happens to be, it was a degree 3. Now this is a degree 2. So I now have this, and I believe that's factorable. And what multiplies to -16 adds to -8. I'm thinking -8 and +2. So I'm going to get x equal 8, x equal -2. And don't forget, we also had x equal 3. And it wanted the sum of them. So if I was to add these together, 8 plus a -2 plus 3, that is going to end up giving us a 9. And that would have been the sum of your solutions. On number 6, at what point would the graph bounce? So the graph bounces when you have a double root, which is a square. So it's going to bounce at x equal 1 because it is a double root because of the x minus 1 squared, because of the square. Seven, what is the degree of the polynomial function? So when it's in this form where they're multiplying out, you are going to take this, which is a 5, plus this, which is a 2, plus this, which is a 3. The 18 is just a number. That would be degree 0, so that's not going to increase this. So that's going to be 7 plus 3, 10. This is degree 10. So looking at number 8, okay, we want to write the polynomial. So first off, let's look at our zeros. Okay, I'm just going to kind of zoom in. So I got a 0 here, here, and here. So this, let me color code them. So this -3 is going to come from x plus 3, and it's going to be squared because it's a double root. The 3 is going to come from an x minus 3, and that's a single root because it goes through, straight through. And this 8 is going to come from x minus 8. And then what we need to do is we want to find our a. And we're going to use a point. Let's use this point right here to plug in. So I'm going to have -2 is equal to a times 0 plus 3 squared plus times 0 minus 3 times 0 minus 8. So -2 is equal to a times 9 times -3 times -8. So let me take 9 times -3 times -8. I end up with a 216. So I get -2 is equal to 216a. So -2 over 216, or that can reduce down to -1 over 108. So my final answer is going to be y equal -1 over 108 times x plus 3 squared times x minus 3 times x minus 8. And that is going to be our answer. Okay, on number 9, we want to write an equation of a sine function with an amplitude of 3, period 4 pi, phase shift negative pi halves, and vertical shift of negative 2. So it should be y equal a times sine b times x minus h plus k. The amplitude of 3, that's going to give me my a. My b is going to come from my period. Now my period is 2 pi over b. And since the period equals 4 pi, when I work that out, I get 2 pi equals 4 pi b. I'm going to divide by 4 pi. And I'm going to get b is equal to 1/2. So my b is 1/2. And then this phase shift of negative pi halves, that's going to come from an x plus pi halves. And then the vertical shift of a negative 2 minus 2. And that's our equation. On number 10, it asks us for the end behavior. So even degrees. Okay, so a positive even degree should be like a parabola. It should be starting and stopping above. A negative even is going to be like a upside down parabola. It's going to be going like this. When we are dealing with an odd, a positive odd is like an increasing line. It's going to be starting below and ending above, going in opposite directions. A negative odd is going to be like a decreasing line. It's going to start above and end below. So let's check the degree of this. So I've got a 3, a 2, and a 5. So that's going to give me 10. And it's negative. So I'm going to be starting below, ending below. What is the phase shift of the function y equal negative cosine negative pi fifths x minus pi thirds? Okay, phase shift. Phase shift is what makes this 0. So I'm going to take pi fifths x minus pi thirds, set it equal to 0 and solve. So pi fifths x equals pi thirds. I'm going to be timesing this top and bottom by the reciprocal 5 over pi, 5 over pi. And when I do that, that's going to cancel, that's going to cancel, I get x. That's going to cancel, that's going to cancel, I get 5 thirds. That's my phase shift. I'm starting at 5 thirds. Number 12, what is the period? So the period is found by looking at the number in front of your b. In front of our x, that's our b. So our b is going to be pi fifths. And so our period for our cosine is 2 pi divided by b. So that's going to be 2 pi divided by 2 fifths. So that's 2 pi times the reciprocal 5 over pi. So my pi cancels and I get 10. So my period is 10. On 13, sine theta is equal to the square root of 2 over 2, and theta is in quadrant 2. So I'm going to be here because that point here is negative root 2 halves, positive root 2 halves. Okay, just in terms of where I'm at on the unit circle, the angle is 3 pi that force. They didn't ask us for the angle, but that's the angle. They want the tan here, and tangent is y over x. So I'm going to have root 2 halves, which is my y, over negative root 2 halves, which is my x. And as complicated as it looks, it's the same over the same. It's a -1. That's your tangent. Um, 14. So what I would do, instead of trying to go around the circle over and over again, take 3 into 34. So 3 goes into 34 11 times, which is 33, with 1 left over. So basically, this is the same as 11 and 1 pi thirds. So all of my even pi's are over here. All of my odd pi's are over here. So pi, 3 pi, 5 pi. So as I'm going around the unit circle over and over again, eventually, I'm going to end up here, which is going to be my 11 pi. And then I need to go a third beyond. And so a third beyond would be right here. And I want the sign of that. And so this point, if I'm trying to figure out what's happening here, is going to be from my origin. Hold on. It's going to be short, comma, long. Short, comma, long. And I want the sign, which is your y coordinate. And so the answer is going to be negative root 3 over 2. On 15. Okay, this is where we have to get common denominators. I'm going to factor. I'm going to factor a 3 out here. This is a difference of 2 squares. This is an x plus 4, x minus 4. I have to be careful that minus between needs to distribute. So in terms of getting a common denominator, my common denominator is going to be a 3, an x minus 4, and an x plus 4. I need all of those. This one here is missing the x plus 4, so I'm going to multiply top and bottom by x plus 4. This here is missing the 3, so I'm going to multiply top and bottom by 3. So I'm going to get 8x plus 32 minus, and so it's going to be 3x plus 9. Again, that minus is distributing to the whole thing. So I'm going to have 8x plus 32 minus 3x minus 9 over this. When I clean that up, I'm going to get a 5x plus 23 over 3 times x minus 4, x plus 4. And that's your answer. And that's the end of this first review for the final exam.